So, good day everyone. So today we are going to tackle about the web networks and system protection. And for our learning outcomes, so at the end of this unit, the students should be able to first understand the fundamentals of web application security in modern web applications. And then after which, we're going to identify the common web vulnerabilities and the various forms of injections. And then the last part would be the application of or apply the essential web application security controls. So these are the input validation, the output encoding, security session management, and so on. So to start with, we have here the brief history of our software security. So how did it all start? Okay. So as the system evolves, to transmit, to process, and to store information, individuals also began to find ways to break, manipulate, or bypass these systems. So, one of the earliest and most significant example of security through encryption is the Enigma machine. So, the Enigma machine is developed in the early 1930s. So here is an image of what an Enigma machine looks like. So here, this machine is a famous encryption device used by the Germans. It was used during the World War II to transmit the coded military messages. So it uses an electric powered mechanical rotors to encrypt and decrypt the text-based messages over radio waves. So each press of these altered motor positions, it produces a different encrypted output each time. So this mechanism is or relied on a substitution encryption. Okay, so this is the basic encoding technique in which letters are replaced with other letters. So this is just like how the CSRF works. So here, let's have an example. So for the substitution encryption or the Caesar cipher, where each letter in the alphabet is shifted by a fixed number of position. So for instance, with a shift of 1, the A becomes B, the M becomes N, the Z becomes A, and for the shift of 3, the A becomes D, the B becomes E, and so on. Now next, let's go with the Bombay by Alan Turing. So, the Enigma machine was ultimately broken by the Bombay. Okay, so this is also an electric-powered mechanism or electric-powered mechanical device designed to reverse engineer, okay, the rotor setting of the Enigma machine. So, by analyzing intercepted messages, the Bombay automated the process of testing possible configurations. So, this breakthrough demonstrated a key lesson that still applies today, which is there is no security system that is unbreakable. They are only resistant. Okay? And for the last part of our history for the software security, we have our telephone phreaking and anti-phreaking. So, one of the next major development in security history came with the widespread adoption of the telephones. So telephones, they enabled rapid or long distance communication and requires a large automated networks to operate efficiently. But as this network expands, some individuals discovers that the telephone system relied on a specific audio tones for routing calls. Okay? So by producing this type of or this kind of frequencies, the users could manipulate the network to gain unauthorized access to services. So such as making a free long distance calls. So here, the hobbyists or we call them hobbyists, no? who experimented with exploiting these weaknesses became known as freakers. So hobbyists becomes freakers. So an early type of hacker who specializes in breaking or manipulating telephone systems. So as a response here, that's why we have our anti-freaking technique. It was developed and represented early defense security measures. So this back and forth evolution between attackers and defenders laid the foundation for the modern cybersecurity. Now let's go with the types of web application vulnerabilities. So we have here two broad categories of um, web application vulnerabilities. First, we have the technical vulnerability. So technical vulnerabilities, these are the classic hacks where an attacker exploits a mistake in an actual code or software configuration. So, for an example, according to the source, which is the UK Information Commission Office official report in 2015, um, the TokTok SQL injection case. So, what happened is that the hackers used a common tool called the SQL map, okay, to find the vulnerability in a legacy Tiscali web page that the TokTok had acquired. So they injected the SQL commands into the search field to bypass the security and download a database. So the flaw here is that the website didn't sanitize the user input. So it treated the attacker's type commands as an instruction for the database rather than just a text. So here the impact of that is that 150,000 customers or more than that, they had their personal data stolen, and the TokTok company was fined about $400,000. Okay, so that is on 2015. So the result of or the technical vulnerabilities, it results from insecure programming techniques. So it often requires a code level changes to mitigate and can usually be detected using automated scanners. As for our logical vulnerabilities result from flawed application logic or decision or poor trust decisions. So often, it requires an architectural or design changes, and the detection is typically requires a human analysis and context understanding. So, an example of our logical vulnerability is that in the report of the Facebook official security update in 2018, there was this case about the Facebook view as token. So what happened is that the attackers exploited a flaw in the view as feature, which lets you see what your profile looks like others. So by using this feature in combination with a video uploader bug, they could generate actually an access token, no, for the person they were viewing. So the flaw here is that this was a logical chain. So the view as feature in the Facebook incorrectly granted a digital key or what we call the tokens to the viewer instead of just showing a preview. So there was no broken code in the traditional sense, yet the feature just interacted in an unintended way. For the impact of that, approximately 50 million accounts were potentially exposed. And for our web vulnerabilities, so common web vulnerabilities, we have to understand it because this is the first step towards securing our web applications. Here the OWASP or the Open Web Application Security Project has its list to highlight the most critical web application security risk. Okay, so before we go on with that, we have here our platform level vulnerabilities, administration level vulnerabilities, and application level vulnerabilities. So this is where the areas where the web vulnerabilities usually occurs. So for the platform vulnerabilities, these are known vulnerabilities that can be exploited with minimal skills. So common targeted by the kiddie scripts, and these are easiest to defend through proper patching and updates. It also requires streamlined patch management procedures. For the administration level vulnerabilities, this is more difficult to correct than known platform issues. So it requires increased security awareness. It involves misconfiguration, outdated files, and leftover components. So backup or remnant files may be exposed, the source code or the database credentials. And for the application level vulnerabilities, the security is often not integrated into standard coding practices. So the input is assumed to be valid and not properly tested. Malicious inputs can also inject scripts for later execution without the admin knowing it instantly. And the error messages may reveal internal applications or database structures. Now, so unchecked database calls can be exploited to access sensitive business data. Now, proceeding with the application security threats. So, again, for the um, open web application security project, they have top 10 list. Okay. First, we have the injection attacks. For the injection attacks, we have three subcategories. So we have the SQL injection. So this SQL injection occurs when an attacker inserts a malicious SQL code into a query. So it can manipulate the database. So a real life example of this is the breach in 2023, no, the move it transfer breach. So what happened is that the attackers exploited a zero-day SQL injection vulnerability into the move it, no. So they managed to transfer files over the software. So by sending this the special crafted HTTPS request to the web application, they were able to inject the commands into the database. And as a result of that, the this allows the attackers to gain unauthorized access to the database, steal the sensitive files from thousands of organizations, and also they can even install web shells to maintain a permanent access to those specific computers. So the impact of this is that unauthorized access to data and data modification, data deletion. And how can we prevent it? So simply by using a parameterized queries, storing procedures, and the ORM frameworks, we can validate and sanitize our user inputs. Next, we have the command injection. Command injection occurs when an attacker injects arbitrary commands into a system command execution. So, for example, a shell shock is one of the most famous examples of command injection, no? Because it affected the bash shell that is used in the Linux and Unix system. So this is a real case in NIST National Vulnerability Database. So this comes from them. And the result is that the attackers could hide the malicious OS commands inside the environment variables. So, like the user agent string in a web request. So, the web server processed the request and then it accidentally executed the hidden commands. Okay. So, for example, a simple web request could be used to force the server to send its password file like etc. or password back to the hacker. So execution of arbitrary commands on the server. And for the prevention, we can prevent this by avoiding executing system commands with input users. So using safer APIs and escape inputs. So we can do that. And then for our XML injection, this one occurs when an attacker injects a malicious XML content into an XML parser. Okay, so here, impacts of that XML injection are data theft, denial of service, or unauthorized access. And for the prevention, we can prevent it by validating and sanitize the XML inputs and also use secure XML parsers. So next we have our cross-site scripting or XSS. So this one involves injecting malicious scripts into web pages viewed by other users. So session hijacking, defacement, redirection to malicious sites. Those are the impacts of the cross-site scripting. And how can we prevent it? So we can prevent it by doing an escape user inputs, using content security policies or the CSP, and implement a proper input validation. For next one, we have the cross-site request forgery. So this one, on the other hand, occurs when an attacker tricks the user into performing an action on a web application where they are authenticated. Okay. So example of this is that for example, you are logged in into your Facebook account, and then you see a random link and you click that link on a random site, and then that site redirected on another website which has a title, see who viewed your profile, something like that. So that site has a hidden form that triggers a post request to share your information. So because you're already logged in, your browser sends the request with your credentials and you accidentally post a spam link on your wall. So it will be redirected on your Facebook account wall. Next we have, before we proceed, to prevent the cross-site request forgery, we can use an anti-cross-site request forgery tokens. We can also validate the links or the URLs, refers headers, and requires user re-authentication for sensitive actions or multi-factor authentication as they call it. Next, we have the session management issues. So we have here two categories of session management issues. One is the session hijacking. So this one occurs when an attacker steals a valid session token and gains unauthorized access. Okay. So for example, you are in a public mall Wi-Fi. So you log in into your school portal at a coffee shop. And then, an attacker on the same Wi-Fi uses a tool, somewhat like a packet sniffer, to grab your session ID without you knowing it. So, the attacker puts that ID into their own browser, and then the server thinks that the attacker is you because the session ID is your session ID, which was grabbed by the hacker. Okay? So, they will gain a full access without needing your password. It will be redirected. For the prevention, we can use the secure cookies with HTTP and only and the secure attributes. So the HTTPS. Implement a proper session expiration so that after expiration, you're going to log in again. Okay? And also to regenerate the session ID on logins. For the next one, we have the session fixation. As for the session fixation, this occurs when an attacker sets the user ID, okay, or the user session ID to known value. So, for example, you have a shared computer in an internet cafe. An attacker opens a banking site in a browser, and then he gets your session ID. But it does not log in, or it is not logged in yet. So they are going to leave the tab open, no? So you sit down on the same PC, and then you log in without you knowing that there is an open tab that was leave on there. So the website keeps using that session ID that was created by the attacker, and then the attacker who already knew that ID can now refresh their browsers at home and can be logged into your system. Okay, so that's how they um, access your information. And then next we have the insecure direct object references, or the IDOR. So this one occurs when an attacker manipulates input to access unauthorized objects or resources. So example, the university portal ID swap. So you log into your school portal to see your grades, and the URL is somewhat like csu.edu.ph. You have view grade, and then you have the student ID at the end of the URL. So you manually change the URL, the end of the URL, to other student ID number. If you do that, if the system shows your classmates' grades instead of giving an access denied error, then the application has an IDOR, or IDOR vulnerability, because it didn't check if the requester owns that specific ID. So we can prevent this IDOR, or the insecure direct object references, by implementing a proper access control and authorization checks also, to avoid exposing direct object references. Next one, we have the security misconfiguration. This one happens when a default configuration or insecure setting are left unchanged. So, potential exposure to sensitive information or unintended access to the application components are the impact of security misconfiguration. But we can also prevent this. So how can we prevent this? We can prevent this by regularly reviewing and updating the configurations. So disabling the unused features and following the security's best practices. Next one, we have the broken authentication and authorization. So we have here two categories or types. We have the broken authentication and the broken authorization. Let's start with the broken authentication. So this is a weak authentication mechanism that allows attackers to bypass a login control. Okay? So the unauthorized access to other accounts can be an impact of broken authentication, but we can also prevent this. All of the security threats have preventions. Okay, so prevention is that implementation of a multi-factored authentication, the use of security password policies, and protect login mechanisms. And then for the broken authorization, this one on the other hand is the failure in enforcing user permissions. So it allows unauthorized actions and access to restricted functionality or data. But prevention for the broken authorization can be enforcing a strict access control and conducting a regular authorization reviews. Next one, number 8, we have the sensitive data exposure. This one takes place when a sensitive data is not properly protected or is exposed through vulnerabilities. So, like data breaches, loss of user privacy, and so on. this sensitive data exposure, we can prevent this by encrypting a sensitive data both in transit and in at rest. So, using a strong encryption algorithms, we can limit data exposure. And number 9, we have our broken cryptography. This one rises when a cryptographic algorithm or implementations are weak or flawed. So, compromise the encrypted data and unauthorized access may be an impact of this one. But for the prevention, we can use up-to-date on and proven cryptographic libraries to avoid weak or outdated algorithms. Number 10, we have the denial of service and distributed denial of service. So the DOS and the DDoS. So these are attacks that flood the target system with excessive traffic, which cause later on service disruptions. So impact of this, server downtime, degraded performance, and something like that. For the prevention, I guess we can implement, no, I believe we can implement a rate limiting or use a DDoS protection services and design resilient infrastructure. Number 11, we also have hijacking. So this one involves a tricky user into clicking on something different from what they perceive. So unauthorized actions performed on behalf of the user is an impact of this one, the click jacking. But to prevent this, we can use the X-frame operations or X-frame option header to prevent framing and implement hijacking or clickjacking defenses. And number 12, this is the most common one. We have the malwares. These are the malicious software injected into the web applications or distributed through it. So it compromises the user system or data, but we can implement an anti-malware solution for this one. It to regularly scan for vulnerabilities and educate the users on safe practices. Next, we have our web application security principles. So the CIA triad. So this one is very popular when it comes to security principles. So first we have availability, I should say. For the availability, this ensures that the information and resources are accessible or available to authorized users, especially when they needed it. And then number 2, we have our integrity. For the integrity, this ensures that the information is accurate and has not been tampered with anything. And number 3, the confidentiality. So confidentiality ensures that sensitive information is accessible only to authorized individuals. So this makes up information security. Okay. For our web security solutions, so we have the threats. On the other hand, we have the solutions for those types of threats. Okay. This security solutions encompasses a set of technical, procedural, and organizational measures designed to protect a web application from security threats and vulnerabilities. So this solution addresses the entire application lifecycle, including the secure design, development, deployment, and maintenance. Okay. So first one, we have the authentication and authorization. So these are the fundamental concepts in web application security, and they play important role in managing user access and also ensuring security interactions between or the web applications. Okay. So for the diagram, here we can see this illustrates an authentication 2.0 process. So this allows an application to access the user's data securely without their password. So in this process, we have here the resource owner. It gives permissions to the application, or this one, the client, to access a certain information. The client then requests the authorization from the authorization server, okay, which verifies the user's identity and issues an access control or access token. This access token now acts as a secure key that the client uses to request data from the resource server or the API. So the resource server checks the token and provides access only if it is valid. So this method improves the security because the user's credential are not shared and accessed and can be limited or revoked at any time. For the authentication, this is the process of verifying and identifying of a user or system. You are going to identify the identity of the user or the system itself. So there are several authentication mechanisms actually. First one, we have the password-based authentication, wherein this is where the users must provide a username and a password to be able to access the website. And the password should be hash to ensure security. So we always have to remember this one. Next one, we have the two-factor authentication. So this one adds a bit of an extra layer of security by requiring a second form for verification. For example, after inputting your password, there is a 4-digit code that is sent to your mobile device. And then next, we have a multi-factor authentication. For the multi-factor authentication, it uses multiple factors for authentication, such as something the user only knows or questions the user can only answer, something that the user has, or something that the user likes, like user is. For example, biometrics, the facial recognitions, we have that. Aside from those types of passwords, so we have multiple factor authentication. And then for the authorization, this one is the process of determining what an authenticated user is allowed to do. So it controls the access to resources and actions based on user permission. So some of the authorization usually used are, first, we have the role-based access control. This is an assigned permission based on the user controls, wherein the users inherit the permission associated with their assigned roles. So the attribute base is the next one. So for the attribute base, this grants access based on attributes or of the user. So example is the user role, the user time, the time of the day, and so on. For the mandatory access control or the MAC access, this one is determined by a centralized authority and it is often used in a high security environment. So this one is for big companies. So another one, we have the last one, we have the discretionary access control or the DAC. So the owners of resources have control over who can they access their resources. Number 2, we have two categories or two types. We have the SSL and the TLS. For this one, let's proceed first with the security socket layer. So this secures online communications by encrypting data to prevent eardropping while verifying the server's identity. So to protect the servers or to protect the users from the imposters. So it further ensures that data integrity by using cryptographic checks to guarantee that information is not altered or tampered with during the transmission phase. So this one here, we have the diagram for the public key encryption. So this works to secure the communication between the user and the servers. So in this process, the server shares a public key with the client user, which is used to encrypt data before sending it over the internet. And then once the data reaches the server, it is decrypted using a private key that only the server possesses. So this ensures that even if the data is intercepted during transmission, it cannot be read without a private key. So the process provides confidentiality and protects sensitive information such as login credentials and personal data during communication. Next, we have the transport layer security. So this diagram here shows how the client or the user and the server establishes a secure connection. So before the exchange of data, the client and the server performs basic connection using sync or ACK messages. These are also called TCP handshakes. So when the client sends a client hello, which includes supported encryption, the server will respond in server hello. So it will be act as a certificate to confirm that the encryption is good. So the client then verifies the certificate and sends the key exchange. So this process ensures that all data exchange afterwards is secured, private, and protected from interceptions. Now, for the primary purpose of the transport layer security, first we have encryption. Second, we have the authorization and authentication. Third, we have the data integrity. Number 3, we have the session management. For the session management, this refers to the process of handling user sessions. So this includes user creation, user maintenance, and termination of sessions within the web applications. So it controls how users interact with the application and how their identity and data are protected. So the key concepts of session management are the session ID, something like that. And then we have here a session management process. So what happens here is that this one shows the connection between the browser or the client and then the website or the server. So when the user first visits the website, the server creates an anonymous session token, okay, and then sends it to the user or browser, okay, to track the user's activity. As the user navigates, these tokens is included in each request. So when the user logs in by submitting username and password, the server verifies the credentials and upgrades the session into a login session token. So from the not permanent token, it becomes login session token. So this new token is then used for authenticated actions, such as, for example, checkouts. And then for every request, the server validates the token to ensure that it is valid and that they belong to the correct user. So the process allows the system to maintain a user identity and security across multiple requests. So we have the session creation. So the terms we have to remember for the session management are the session creation, which involves authentication and session tokens. We also have the session management, wherein we have our session storage and the session token management. And the session termination. For the session termination, we have the logout and the session expiration. Next, we have the input validation. For the input validation, it ensures that all data received from user is checked, filtered, and sanitized before being processed by the application. So, proper input validation helps to protect the web applications from various types of attacks. So, this includes like the injection attacks, the cross-site scripting, and the data corruption. So, there are two types of input validation. First one, we have the client side input validation. For the client side, this one provides immediate feedback to users and reduce the number of invalid requests to the server. On the other hand, the server-side validation ensures that all data received from the client is validated before being processed. So this is considered as the primary defense mechanism since it cannot be bypassed by the users. It will be the end of our topic for today. Thank you.